All right, now let's get back to the sketchpad here and let's write some functions which will allow us to create a new stack, add a number or a value to a stack, and remove a value from a stack. So let's start with creating a stack. So creating a stack is just a function that returns a stack pointer. So that's stack pointer, create a stack, and basically it takes nothing and it returns a stack. So to create a stack, all we have to do is to, so here I'm not gonna sort of write C code, I'm gonna just use pseudocode to make the idea clear. But then when we write the code, when we translate the code to C, then we're gonna use the correct syntax. So basically we're gonna create a stack, okay? So that's a stack. Sorry. So that's a stack S, which we will create a stack S, and we're going to allocate, make the allocation, the required allocation for that stack S. So we're gonna allocate S, okay? So S is going to take some address, some memory. Now, after creating the stack, we're going to have to initialize the stack. So we said that the stack contains two properties. The first one is the size. So its size will be 0. It's initially empty. And then its top pointer will be null, which means that the stack is not pointing to any existent stack node. There's no values, there's no nodes that is pointing at. It's empty, just empty. So this is the first function. So let's just write it. So that's stack pointer create stack. It takes no parameters and it create a stack. So that's a stack pointer S equals, and we're going to allocate some memory for that stack structure. So size of stack. And of course the malloc will return a void pointer, so we have to cast that to stack pointer, not a void pointer, so that we do not get any warnings or errors during compilation. All right, now since the stack has been allocated, then we can initialize its size and top properties. So its size will be 0 and its top pointer will be initially null. And finally, we're just going to return that stack. Cool. Now, the next thing that we might need to do in a stack data structure is to create a function that will allow us to check whether the stack is empty or not. So basically just a Boolean function which will test whether the stack is empty. So it'll be something like this: empty stack, takes the stack S, and it returns whether the stack size equals 0 or not. So if the stack size equals 0, that means that the stack is empty. Okay, so we will return true. Otherwise, if it is different to 0, it means that the stack is not empty, so we return false. So let's write that function. So this function returns Boolean. For that reason, we have to include the Boolean library, so include std_bool.h. And then the function is called empty stack. So that's empty stack. It gets a stack pointer S, and it returns whether the S size equals 0 or not. Cool. Now we might need to create another function that would add a number to the stack. So I've explained earlier, a couple of minutes ago, the process of adding an element. So I'm just gonna write the pseudo code of it. So it'll be a function that returns nothing, and it's called push stack, which means that we're adding a value to the stack S. So we're adding value to S. So that function basically the first thing we said that it would create a new stack node. So stack node N. So that's a node. We're going to allocate the required memory for that node, and then the node value takes the value that we want to add, and the nodes next takes whatever the node that the head was pointing at, or the top was pointing at. So that's S top. Okay. We said that if that's the size, this is the stack. So we said that if our top was pointing to some node here, which is pointing to a bunch of others, and we want to add another node, then the first thing that we would do is we would fill the value of the new node, and then we would make the next of the new node equals the content of the top. So it points to the same place. Okay? And then finally we have to update the stack top to point to the newly created node. So that's S top would equal N. And of course, whenever we add something to the stack, we have to increment the size of the stack. So size plus plus. The stack size gets incremented. And finally, we have to return that, well, we're not going to return anything because it's just a void function. So basically that's it. This code would create a new node, fill it with its value, and connect it correctly, and increment the size of the stack. So let's code that. So it is a void push stack function that takes a stack pointer S and a value that we want to add. We said that the first thing we would do is to create a new node, a new stack node. So that's stack node pointer N equals, and of course we have to cast that. So stack node pointer, that equals to malloc of size of one node, one stack node. So we just allocated the required memory for a stack node, and then we took the address of that newly allocated address, and we copied that into N. So N points to that allocated address. Now we have to, that allocated space, sorry. So we have to fill the data of that newly created stack node. So N value takes the value, and N next takes S top, and then finally the S top takes N. And of course the S size gets incremented. And basically that's it. That's how to add an element to this stack. Now the final thing that we need to implement before testing our stack is a function which will allow us to pop elements from the stack. Okay, so let's write that function. So it'll be some function that will return int, and let's call that pop stack. So it'll pop a number from the stack S, and it'll return it as a function return value. So the first thing we have to do, we said earlier that if we have a stack that has that has a size, and it has a top pointer. That's a top pointer, and the top pointer points to some node which has next pointer that points to some other node, and so on. And we have, let's say here we have some value 8, and here let's say we have some value 9. So we're interested to pop out the value 8. We have to remove the value 8 from the stack and return it, and of course delete this entire node. So the first thing we have to do is to copy that value from the node, from the first stack node that we are pointing at by the stack data structure. So let's copy that. So int value, so we create a new value variable and we copy inside it the top value. So this is the stack S. It has two fields, size and top. Now we are interested about top. Top is a pointer that points to a structure. The structure contains a value and a next property. So we are interested about the value property. Okay, so we're extracting the 8 from there. Okay. So after we copy that over, we have to create a new pointer which will hold the address of this node, because we have to delete this node. So we have to copy its address so that later we can delete it. We know where it is, so we can free it from the memory. So let's create that. So we're going to create a stack node pointer. Let's call it SN, a stack node. And it is, of course, a pointer that will take the address of S top. And then we're going to make S top equals S top next. It means that instead of pointing to this node, we're going to point to its next. Now, this is its next. Okay, the node that contains 9 is the next of the node that the top is currently pointing at. So instead of pointing to that, we're going to point to its next. So we're going to point here. Okay? So let's do that. Let's write that. Yeah, we already written that. Okay. And then after that, we have to free this node. We have to delete it from the memory. We don't need it anymore. So we're going to free. And we know that that node is stored at a pointer called SN. So we're going to free SN. And of course, we have to decrement the size. So the size property gets decremented by 1. And the final thing we have to do is to return the value that we have extracted. And basically that's it, the function. So let's try to code it using C. So we said that the function is titled pop stack. Pop stack will take a stack S, and it'll return the element at the top, the value, the number at the top. So we said that the first thing that we have to do is basically to create a value variable which will hold the S top value. And then we said that we're going to create a stack node pointer SN, which will contain the address of the node that we want to delete, which is S top. And then we are interested in incrementing S, so S top takes S top next. Okay? And then we have to decrement the size. And then we have to free the SN. And finally, we have to return the value that we came for in the first place. So basically these are the 4 basic and fundamental primitives that you can find for stack data structures. Basically the data structure nodes and the data structure header that contains where the node starts, and a function which will allow you to create and initialize a data structure, a stack, a function which will test whether the stack is empty or not, a function which will allow you to add a value to a stack, and a function which will allow you to remove an element from the stack. And of course, we're always talking about adding from the top and removing from the top. So let's use these primitives. Let's use this stack. Let's test it out. So we create a stack pointer. Let's call it S equals create stack. Cool. Now we've created a stack. Now let's fill the stack with some information. So push stack, and we give it the stack S and the value that we want to push. Let's say we want to push 5. And let's do it again with a couple of other values. So let's push 9, and let's push, say, 3, for example. And now I'm going to iterate through the stack, always extracting an element and then printing it out, okay? Extract an element, pop an element, print it, pop it, print it, and so on. So while the stack is not empty, so while not empty, stack S, while S is not empty, we're going to pop an element and then print it out. So we're going to print F, an integer separated by tabs, and basically we're going to print pop stack S. So every time we're going to pop a value from S, and then after doing that, we are going to print it out. Okay, so pop a value and then print it to the screen. Pop a value and then print it to the screen, and so on until the stack becomes empty. For that, in that case, we're going to quit the while loop. So let's test that. And as you can see, it works. So here we added 593, and then we started popping and 395, and that's the last in, first out property. The last element that we added to the stack was the first element that we extracted from the stack. And the first element that we added to the stack was the last element that we extracted from the stack. And basically that's it. That's how to implement a stack and how to use it. Thank you again.